Hello dear students, welcome back. In this video we are going to start with beta function and its property. So let us first start with beta function. The beta function of mn is denoted by beta mn or sometimes b of mn and is defined by integration, that is 0 to 1 x raised to m minus 1 into 1 minus x raised to n minus 1 dx, which depends on the parameter m and n. Thus we can write beta mn is equal integration, that is 0 to 1. So x raised to m minus 1 into 1 minus x raised to n minus 1 and to dx. So now let us see property of the beta function. So beta mn is equal beta nm. That can be written, but let us see how we can prove it. So according to the definition of the beta function, we can write beta mn is equal integration, that is 0 to 1 x raised to m minus 1 into 1 minus x raised to n minus 1 dx. But now I'm just going to assuming that the 1 minus x is equal, that is y. So what you can write, that is x is equal 1 minus y. So when we differentiate on the both the sides, so what we will get, dx is equal, that is the minus dy. But when x is equal 0, so what I will get, y is equal, that is 1. But x is equal 1, so what I will get, only y is equal, that is 0. And therefore our beta mn can be reduced to form integration 1 to 0, x is replaced by 1 minus y raised to m minus 1 and 1 minus x is nothing but y, so y raised to n minus 1 and dx is nothing but, that is the minus dy. So I can write minus dy. But here minus is there. So when I interchange this limit, so what I will get, minus into integration, that is 0 to 1, but minus is already there, so it will be the plus. And therefore we have y raised to n minus 1 into 1 minus y raised to m minus 1. But according to definition, so what I can assume, that beta of m and n, so here it is the same, but only just variable is changed. So I can represent this is the beta n m, and this is the proof of this property number 1. Now we have the property number 2. Beta mn is equal to times integration, that is 0 to pi by 2 sine raised to 2m minus 1 theta cos 2n minus 1 theta d theta. That means we need to consider beta function in the polar form. So what I'm just going to start with according to definition of the beta function. So this is the definition. Now we have to assume that x is equal sine square theta. So when I differentiate on the both the sides, so what I will get, dx is equal 2 times sine theta cos theta d theta. But when x is equal 0, so what choice of theta, it will be the 0, so we cancel theta is equal 0. X is equal 1, so for what choice of theta, sine square theta will be the 1, so we cancel theta is equal pi by 2. So beta mn is equal integration, that is 0 to pi by 2, so it will be the reduced form, and x is replaced by sine square theta raised to m minus 1, 1 minus sine square theta raised to power n minus 1, 2 times sine theta cos theta d theta, because dx is nothing but here. So whenever we simplify, so what I can write 2 times, because this is the 2, so 2 times integration, that is 0 to pi by 2 sine square raised to power m minus 1 is there, so we can write square root to m minus 2. And here 1 minus sine square is nothing but cos square, and cos square raised to n minus 1 is there, so it can be written as cos raised to 2n minus 2 theta, and sin theta into cos theta d theta is there. But when we simplify, so what I will get, sin theta raised to 2m minus 1, and again what I can get from here, cos raised to 2n minus 1 and then d theta. So beta mn is equal to times integration, that is 0 to pi by 2 sine raised to 2m minus 1 theta into cos raised to 2n minus 1 theta d theta. So this is the proof of property number 2. Also you can assume that beta mn is equal 2 times, that is integration, that is 0 to pi by 2 sine square raised to 2m minus 1 theta cos raised to 2n minus 1 theta d theta. But what I'm just going to assume, that 2m minus 1 is equal, that is p, and 2n minus 1 is equal, that is the q. So from this what I can get, m is equal, that is p plus 1 divided by 2, and the same n is equal, that is q plus 1 divided by 2. But when I replace m and n here, so what I will get, integration that is 0 to pi by 2 sin raised to p theta cos raised to q theta and d theta is equal, just take 2 on the left hand side, so we can write 1 by 2 into beta of mn, but m is nothing but p plus 1 divided by 2 and n is nothing but q plus 1 divided by 2, and this is the formula. Whenever it is required we will use it. Now we have the another property, prove that beta mn is equal integration that is 0 to infinite x raised to m minus 1 divided by 1 plus x raised to m plus n dx. But now using the definition of the beta function, so first definition of the beta function is there. Now I have to assume that x is equal y divided by 1 plus y. So when we differentiate on the both the sides, so what I will get, dx is equal 1 plus y minus y divided by 1 plus y whole square. So y will be eliminated, so I will get 1 divided by 1 plus y raised to power 2 into dy. Now I have to change the limit. So what I can say, x is equal 0, so what I can say, y must be what, exactly 0. Otherwise this form also you can write that x into 1 plus y is equal y. So what you can write, that is x plus xy is equal y. But when you make y as a subject, so what you can write, when I take on the right hand side, so I will get 1 minus x is equal, that is x. So from this we can get y is equal x divided by 1 minus x. So now when we put x is equal 0 here, so what I will get, y is equal 0, so we have this one. But when we put x is equal 1, so what I will get, that is the denominator is going to be 0, so what we can say, y tends to the infinite. So therefore the definition beta mn can be reduced to form integration that is 0 to infinite x is replaced by y divided by 1 plus y raised to m minus 1 into 1 minus y divided by 1 plus y raised to n minus 1, and dx is nothing but 1 divided by 1 plus y raised to power 2 dy. But when we simplify, so what I will get, 1 plus y minus y, so here it will be only 1 divided by 1 plus y raised to n minus 1. But here 1 plus y raised to n minus 1 is there, also 1 plus y raised to power 2 is there. So ultimately what we are going to get, as a denominator we will have 1 plus y raised to n minus 1 plus n minus 1 plus 2. But when you simplify, so what you will get, 1 plus y raised to m plus n. And what about the numerator, that is numerator is going to be the y raised to m minus 1 into 1 raised to something power, that is a finite, so it will be the same. So we get this one. So therefore we have the integration that is 0 to infinite y raised to m minus 1 divided by 1 plus y raised to m plus n into dy. But again, this is what exactly, y is replaced by x, so we can write this one. So this is what, that is our required form. Now we have another property, relation between beta and gamma function. So beta mn is equal gamma m into gamma n divided by gamma m plus n. So according to the property of the gamma function, so what I can write, gamma n is equal 2 times integration that is 0 to infinite e raised to minus x square into x raised to 2n minus 1 dx. But now we need to start with this one. So gamma m into gamma n is equal 2 times integration that is 0 to infinite e raised to minus x square x raised to 2 times n is replaced by m and minus 1 dx, and gamma n that is the same. But for our simplicity, I am just assuming that the variable x is replaced by y. So I can write as a double integration 2 into 2 that is 4, integration that is 0 to infinite, again integration that is 0 to infinite, e raised to minus into bracket x square plus y square. If I assume that this is the y, so I can write this is like that. So e raised to minus into x square plus y square into x raised to 2m minus 1 into y raised to 2n minus 1 dx dy. But when we assume that the polar coordinate, that is x is equal r cos theta, y is equal r sin theta, so what we are going to get, it is going to be contained on the first coordinate. As earlier we have said that whenever we have the on the first coordinate as an infinite unbounded region, so what we can assume, that radius will be, that is r is equal, that is 0 to infinite, and theta as the first coordinate, so what we can say, theta is equal, that is 0 to pi by 2, and e raised to minus r square, x is equal, that is r cos theta raised to 2m minus 1, and y is equal r sin theta raised to 2n minus 1, and dx dy is what, exactly as usual, Jacobian j dr d theta. But we know that Jacobian j will be on the r and then dr d theta. But when you simplify, so what you can write? So try to understand, this is r raised to 2m minus 1, r raised to 2n minus 1 into r. So when I combine this r raised to 2m minus 1 plus 2n minus 1 plus 1, so what I will get? R raised to 2 into m plus n minus 1, and then after e raised to minus r square cos theta raised to 2m minus 1 sin raised to 2n minus 1 theta dr and d theta. So when I simplify, so what I will get here? First I'm just going to focus on the theta. So integration, that is 0 to pi by 2 cos raised to 2m minus 1 sin raised to 2n minus 1 theta d theta, and 2 times is there. Again I can write 2 times integration, that is 0 to infinite r raised to 2 times m plus n minus 1 e raised to minus r square dr. This is the property of the beta mn, and this is what exactly gamma of m plus n. But when we simplify, so what I will get? Beta mn is equal gamma m into gamma n divided by gamma m plus n. Whenever it is required, we will use this one formula, because this is the relation between beta and gamma function. Now we have duplication formula. Also it is known as the Legendre's formula. Gamma m into gamma m plus 1 by 2, and that can be written as square root of pi into gamma 2m divided by 2 raised to 2m minus 1. Again the property of the beta function, so beta mn is equal to 2 times integration, that is 0 to pi by 2 sin raised to 2m minus 1 theta cos raised to 2n minus 1 theta d theta. But when I replace n is equal m, so what I will get? Beta mm is equal to 2 times integration, that is 0 to pi by 2 sin raised to 2m minus 1 and again cos raised to 2m minus 1. So we can combine these two terms. So what I will get? Sin theta into cos theta raised to 2m minus 1, and d theta is there. But again I'm just going to multiply by 2 and divide by 2. So what I will get? This is what exactly sin 2 theta raised to 2m minus 1, but 1 by 2 is there, so 1 by 2 raised to power is there, that is a 2m minus 1, which is independent of theta, so we can take outside from this integration. So we have 2 divided by 2 raised to 2m minus 1 integration, that is 0 to pi by 2 sin 2 theta into sin 2 theta raised to 2m minus 1 d theta. But on the left hand side, beta mn is what? Exactly relation between beta and gamma function. So we can write gamma m into gamma m divided by gamma of 2n. Now let 2 theta is equal, that is t. So what I can say? 2 times d theta is equal dt. But when theta is equal 0, so what I will get? T is equal 0 and theta is equal, that is pi by 2, so we will get t is equal, that is the pi. But again this is same as this one on the left hand side, but right hand side it will be the change. So integration, that is 0 to pi sin t raised to 2m minus 1, and d theta is nothing but only dt by 2. But when you simplify, so 2 will be the cancel out, so what you will get? 1 divided by 2 raised to 2m minus 1 integration, that is 0 to pi sin t raised to 2m minus 1 into cos t raised to power 0, because cos raised to 0, so this is going to be the 1, so therefore 1 can be replaced by this 1. So now I am just going to apply another formula that you are all familiar, that the integration, that is 0 to 2a f of x dx is equal, that is 2 time integration, that will be the 0 to a f of x dx, whenever f of 2a minus x is same as, that is the f of x. Otherwise we are not going to apply this formula. So here you can see that pi minus pi, so it is going to be the second quadrant, and second quadrant, that will be the same, that means there is no change. So I can write integration 0 to pi by 2 sin t raised to 2m minus 1 into cos t raised to 0 d theta. So we have 1 divided by 2 raised to 2m minus 1 into 2 into integration, that is 0 to pi by 2 sin t raised to 2m minus 1 cos t raised to 0 dt. We know that the property of the beta function, that 2 time integration, that is 0 to pi by 2 sin raised to p theta into cos raised to q theta d theta, and which is same as beta of p plus 1 divided by 2 and the same q plus 1 divided by 2. But when I assume that this is the p, so what I will get? 2m minus 1 plus 1 divided by 2, so I will get only m, and here q plus 1, so it will be the 1 divided by 2, so I will get only beta m comma 1 by 2. And but we know that this is what exactly again relation between the beta and gamma function. So I can write that gamma m into gamma 1 by 2 divided by gamma of m plus 1 by 2. But when we observe that gamma m will be the cancel out, so what I will get, gamma m into gamma of m plus 1 by 2 is equal square root of pi, because gamma 1 by 2 is nothing but that is the square root of pi. So into gamma of 2m divided by 2 raised to 2m minus 1, and that is the proof of the duplication formula. Also it is known as Legendre formula. Now let us see example which are based on the beta function. So find the value beta 3 by 2 comma 1 by 2. Again we know that the relation between beta and gamma function, what was the relation? Beta mn is equal gamma m into gamma n divided by gamma m plus n. So what I can write, gamma 3 by 2 into gamma 1 by 2 divided by gamma 3 by 2 plus 1 by 2, and that will be the what, 4 by 2, that is the gamma 2. But when we apply the gamma n plus 1 is nothing but n into gamma n. So what I will get, gamma 3 by 2 can be written as 1 by 2 into gamma 1 by 2, but gamma 1 by 2 is what? Gamma 1 by 2 is nothing but square root of pi. So I will get 1 by 2 into square root of pi, and gamma 1 by 2 is nothing but again square root of pi. Divide by gamma 2, but when we observe that the gamma n plus 1 is nothing but n factorial whenever we have the non-negative integers. So we will get the pi divided by 2. Find the value of beta 4 by 3, 5 by 3. So as usual, relation between gamma and beta function, so I can assume that the gamma 4 by 3 into gamma 5 by 3 divided by gamma of 3. When we apply the result that the gamma n plus 1 can be written as n into gamma n, so what I will get, 1 by 3 into gamma 1 by 3, and again 5 by 3 minus 1, so it will be the 2 by 3 gamma 2 by 3. But again 1 divided by 3 into 3, that is 9, again 2 divided by 2 factorial, that will be the cancel out, so I will get gamma 1 by 2 into gamma 2 by 3. Again this can be modified to the gamma 1 minus 1 by 3. But we have the one result that the gamma n into gamma 1 minus n, that can be written as pi divided by sine n pi. So according to this result, what I can say that n is nothing but that is the 1 by 3. So what I will get, pi divided by 3. So sine pi by 3, but sine pi by 3 is what? Exactly square root of 3 divided by 2. So it will be written as a numerator. So we can say that 2 pi divided by 9 into square root of 3. Now we have done the question, evaluate integration, that is 0 to 2 y raised to 4 into 8 minus y raised to q raised to power minus 1 by 3 dy. Now what I have to assume, that I have to assume that the y raised to 3 is equal, that is 8 times sine square theta. So what I can write, y is equal to 2 times sine raised to power 2 by 3 theta, but dy can be written as 2 into 2 by 3 sine raised to 2 by 3 minus 1, so it will be the minus 1 by 3, and derivative of the sine will be the, that is the cos theta d theta. But when we put here y is equal, that is 0, for what choice of theta, it will be the 0, so we can say theta is equal 0, and y is equal, that is 2, so what we can say, 2 will be the eliminate, and we can say for what choice of theta, it will be the 1, so we can say theta is equal pi by 2, so sine pi by 2 will be the 1. So we will transform the given improper integral, that will be the 0 to pi by 2, and y raised to 4 is what? Exactly y cube into y. But instead of, I'm just assuming that the y is equal this one, so what I can say, 2 into sine raised to 2 by 3 theta raised to power 4 and 8 minus y raised to cube, and that is we have 8 into sine square theta raised to minus 1 by 3, and dy is what? Exactly whatever we have, just I have mentioned that. But whenever we simplify, so 2 raised to 4, that will be the 16, and sine raised to 8 by 3 theta, and again 8 raised to minus 1 by 3, that will be the common, because both the terms contains 8. So what we can say, that 8 raised to minus 1 by 3 is nothing but 2 raised to power 3 raised to minus 1 by 3, so I will get 2 raised to minus 1, and that can be written as 1 by 2. So we have, that is the 1 by 2, and 1 minus sine square theta is what? Exactly cos square theta, but we can say cos square theta raised to power minus 1 by 3. So what I will get, cos raised to minus 2 by 3, and another is, that is the sine raised to minus 1 by 3 theta and cos theta d theta. But when you simplify, so what you will get, 32 16 2 ja, because 1 2 is going to be the cancel out, so what I will get, that is the 32 divided by 3, And then after sine raised to 8 by 3 theta into sine raised to minus 1 by 3 theta. So what I can say, sine raised to 8 by 3 minus 1 by 3, so it will be the sine raised to 7 by 3, and cos raised to minus 2 by 3 into cos theta. So I can combine these two terms. So what I will get, cos raised to minus 2 by 3 plus 1. So I will get cos raised to 1 by 3 theta. Again, as usual, I have to apply the property of the beta function. So what I will get, 1 by 2 into beta of p plus 1. This is our p, so p plus 1. So what I will get, 10 plus 10 divided by 2, so I will get 5 divided by 3, and another q plus 1 divided by 2. So what I can say, q plus 1, so I will get 4 divided by 3, and again divided by 2 is there, so what I will get, only 2 by 3. So we have 16 by 3 into gamma 5 by 3 into gamma 2 by 3 divided by gamma 7 by 3 using the relation between gamma and beta function. But when you simplify, so what you will get, 2 by 3 into gamma 2 by 3 and gamma 2 by 3 is again the same. And gamma 7 by 3 can be written as 4 by 3 into 1 by 3 into gamma 1 by 3. But when you simplify, so what you will get, 8 times gamma 1 2 by 3 raised to power 2 and divide by gamma 1 by 3. Now we have another question, evaluate integration, that is 0 to infinite x square divided by 1 plus x raised to power 4 raised to power 3 dx. So this is I. Now 1 plus something is there, so you have to assume that 1 plus tan square theta, so that you can get sec square theta. So like that logic, I'm just going to assume that x raised to 4 is equal to tan square theta. So I can assume that x is equal to tan raised to 1 by 2 theta. So dx is equal 1 by 2 tan raised to minus 1 by 2 theta into derivative of tan, that is the sec square theta d theta. But when I put x is equal, that is 0, so for what choice of theta, it will be the 0, so I can say theta is equal 0. And when we assume that the x is equal infinite, so for what choice of theta, tan theta will be the infinite, so we can say theta is equal pi by 2. So our improper integral transforming to integration, that is 0 to pi by 2 x square. So when I take square on the both the sides, so I will get tan theta divided by 1 plus tan square theta raised to power 3, and dx is what exactly we have this 1, so I'll just replace it. But when I simplify, so what I will get, 10 raised to minus 1 by 2 and again 10 raised to 1 theta is there. So when I combine these two, so I will get 10 raised to 1 by 2 theta, and this is 1 plus tan square is nothing but sec square raised to power 3, so I will get the sec raised to 6. And sec square is there, so whenever I simplify this one, so 1 by 2 into integration, that is 0 to pi by 2, tan can be written as what, sine divided by cos. So I can write the sine square raised to 1 by 2 divided by cos square raised to 1 by 2. But when we simplify, so what I will get, that is the cos raised to 7 by 2 theta d theta. But again, this is the property of the beta function. So this is the p. So p plus 1, so 1 by 2 plus 1, that is 3 by 2 divided by 2, so what I will get, that is a 3 by 4. Q plus 1, so 7 by 2 plus 1, so it will be the 9 by 2 divided by 2, so I will get the 9 by 2 into 1 by 2 is there. Again 1 by 2 is there because this is 1 by 2 is the based on the formula that you all are familiar, that the p gamma of beta of p plus 1 divided by 2 into q plus 1 divided by 2 is equal 2 times integration, that is 0 to pi by 2 sine raised to p theta into cos raised to q theta d theta. But when you apply the relation between gamma and beta functions, so you will get this one. But when you simplify, so again using the property that the gamma n into gamma 1 minus n is equal, that is the pi divided by sine n pi. So using that formula, you will get the sine pi by 4 here, but sine pi by 4 is nothing but what exactly is 1 divided by square root of 2. So finally you will get 5 pi into square root of 2 divided by 128. And these are the example for your practice purpose, so do it yourself. So in this video we have discussed about the beta function and its property. Thank you.